Okay, so for solving equations and inequalities by graphing, this is definitely going to require us to do the graphing. So today we're going to review graphing lines, we're going to review graphing absolute value, and graphing parabolas. All right, so the solution to an equation or an inequality are the x values that make the statement true. So sometimes it'll be a single x value, sometimes it's going to be a domain of x values. Use a graph to solve the equation. So here is our plan of action, if you will. So I have the equation 5x minus 7 is equal to 3. I fully believe you could solve that algebraically, right? We'd add 7 to both sides, divide by 5, get an x value. Okay. But the directions are to solve it graphically, and we're going to have to graph when we get onto the homework. So let's do that. Step 1. We're going to graph basically y equals the left side of the equation and y equals the right side of the equation. I'm going to color coordinate. I'm going to use 2 different colors. So if you've got different colors and you want to use like red and blue with me or 2 other colors, great. So I'm going to take y equals this side of the equation, 5x minus 7. And I'm going to graph y equals the right side of the equation, which is 3. I'm going to put both of those equations on the same coordinate plane and then find out where they intersect. Starting off with just 2 lines, right? Trying to ease into it. Remember an equation of the line written in slope-intercept form, y equals mx plus b. Okay, so when I start off, y equals 5x minus 7. B is the y-intercept, so I have a negative 7 y-intercept. So on my graph, make sure that you can go down at least 7 on the y-axis. Just a reminder that no earbuds should be in during learning time. Please make sure they're away. And then the slope is 5 over 1. All right, M stands for the slope. So the slope, I'm going to go up 5 and over 1. 1, 2, 3, 4, 5. And 1 to the right. 1, 2, 3, 4, 5. And 1 to the right. If you have something that you can make a straight edge with, so if you've got your ID out, which should be on your person anyways, or in maybe a phone case, I do have a box of rulers over here if you would like to borrow a ruler. I've been used in some time. Something where you can make this as straight as possible. It's a little harder to do on the tablet. It gets tough to tell where they intersect if I don't make a perfectly straight line. Any questions on graphing the first equation? Y equals 5x minus 7. If anybody would like to hear again why I know the graph intersects at negative 7 or how I got the slope. Then I'm also going to graph y equals 3. So y equals 3. I have no x in it, so I have no slope. All right, so y equals 3 is going to be a horizontal line, which has a 0 slope, and intersects the y-axis at 3. So I go up 3, and then 0 slope means I go up or down 0 and write 1 or 2 or however many. So this is actually going to be a perfectly horizontal line. And let me go ahead and label these. The graphing is the tedious part. Oftentimes the part we need to do over and over again to make sure we're good. All right, so step 1 is to graph. Step 2 is to find the intersection or the intersections. These lines cross in one point and one point only. And that coordinate, every coordinate is always x, y, so I go left or right first, and I count from the origin. So I go right 2, up 3, which gives me the intersection of 2, 3. Only one coordinate where these intersect. Okay, so reminder, I took my original linear equation. I just have 5x minus 7 is equal to 3. And I changed it to set y equal to the left side, y equal to the right side so that I could solve by graphing. So I introduced a new variable y. I'm not solving for y. I'm solving for x. So solution to an equation are the x values that make the statement true. So I only want the x value from these intersections. So the answer is 2. I know you could have taken this equation and told me that x is 2 from the beginning, but then I wouldn't have been solving by graphing. We're also going to do more complicated ones, right? So this is just an introduction. The last step that I recommend you doing is plug in 2 and make sure that it works. Check your work, check your answer. So I'm going to take 2 and I'm going to plug it back into the original equation and make sure that it works. So let's see. My original equation is 5x minus 7. So instead of x, I'm going to plug in 2. And is that indeed 3? 5 times 2 is 10. 10 minus 7 is 3. Yes, it works. I'm going to pause. Take 10, 15, 30 seconds, whatever it takes. Reread those notes. Make sure that you don't have any questions. Make sure that we're all good on this problem before we move on to the next one. So just take a few seconds to reread your notes. Maybe jot anything down. You're like, oh, but I need to remember how to do this. Is there something you need to add that your future self will thank you for? Not if it says solving, graphing, you have to have work. In Pearson, it's going to force you to do the graph.
Okay.
And this is a simplified example that we're starting with, right? So when they get more complicated, it'll make more sense why we should solve by graphing. Okay, are there any questions that I can answer before we move on? If that problem seemed fast, this is your chance to slow me down and ask a question. Okay, so the next one. B. Now I have negative absolute value x minus 2 and absolute value is equal to negative 1/2 x minus 2. I'm going to solve it using the same steps. This time, I have an absolute value on the left-hand side, and I have a linear part on the right-hand side. So I'm going to create two equations. I'm going to set y equals to the left-hand side. And I'm going to set y equal to the right-hand side. Now solving this equation is still, algebraically is still possible. A bit less obvious than the last one. Sometimes when we start planning our graphs, we end up getting to the graphing part and realizing like, oh, this graph doesn't fit here. And then we have to extend it or move it or change it, and that's normal. That's why we do it in pencil. Okay, starting off right here. Y is equal to the negative absolute value of x minus 2. Tell me anything you know about that problem. Yeah.
That's the vertex on 2,
Ooh, the vertex is at 2, 0. Excellent. That is true. Great. Tell me something else that you know about this, what this graph looks like. What's the shape like? Yeah.
Well, it's going to be like a V shape because it's absolute value. It's going to be pointing down.
Great. It is going to be a V shape, and it's going to be pointing down because of the negative, right? The V comes from the absolute value, and down because of the negative. Awesome. Okay, so I know a lot of information. In fact, I might just like jot some of that down. All right, so it opens down. It's a V shape, just so I don't forget. And Jack shared that he can tell that the vertex is at 2, 0. So can you explain how you knew that it's 2, 0? Beautiful. Yeah, so because in the absolute value I have x minus 2, I know that that moves to the right 2 when I look at transformations. And then because I'm adding or subtracting nothing on the outside of the absolute value, I don't have a vertical shift. Beautiful. So 2, 0, I have a point. Boom. It opens down, and I need to be aware of the slope of these lines. I don't have any additional information here where the negative is or in front of x. I don't have any additional numbers, so the slope's just going to be 1. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. Go this direction. And then same thing with the other direction. So down 1, left 1, to make sure that I have that upside down V shape. Okay, so y is equal to negative 1/2 x minus 2. That's a line. I'm going to give you a little bit of a head start because I'd like you to try to graph that on your own, right? Maybe you do it in really light pencil in case you're worried you make a mistake, or maybe you're confident and you do it regular, right? I have a negative 1/2 for a slope and then a y-intercept of negative 2. So go ahead and graph that line. Give yourself a chance to practice graphing. So make sure you have your y-axis of negative 2. seeing a lot of good things. Okay, so the y-intercept is at -2. Make sure that means you go down 2, right? Here's my x-axis, here's my y-axis. Not left 2, down 2. Then the slope. So slope is rise over run. So if I have -1/2, from here, -1 is down 1, and then right 2. Down 1, right 2. If I have a slope of less than 1, then the slope should be more shallow. If I have a slope of greater than 1, then it should be steeper. So this should be more shallow. I know it only takes 2 dots to make a line, but I like to make a lot of dots, try to make it as accurate as possible. Especially when I'm looking for intersections. All right, 2 really good looking graphs. Now I want the points of intersection. I'm going to label these. Y is equal to negative absolute value of x minus 2. Y is equal to -1/2 x minus 2. So I'm making these intersection points kind of bold and green. Hopefully you can see them. The first one is here. So left or right 0 and down 2. And I have a second point of intersection this time. So this other point looks like it's over 8, down 6. So +8, -6. The solutions are only the x values. So I get x is equal to 0 and 8. When I go to check those, to plug them in, I'm going to plug in 0. So negative absolute value of 0 minus 2, is that equal to -1/2 times 0 minus 2? I like plugging in 0. It makes my life easy. So this is a good point to bring up. When I have a negative in front of absolute value, I can never distribute that negative in when I have those absolute value bars. I know I can when it's parenthesis, but not when I have absolute value bars. So I have to take this out of the absolute value first. So this gives me a 2, and then I have the negative in front. So 0 checks out. And then I'll make sure 8 checks out. Let's see, 8 minus 2 gives me 6. Then I have -6 is equal to -6. Yes, that works too. Okay, cool. So x is equal to 0 and 8. Now, this whole section is all about solving by graphing. So is there other ways to solve? Yes, but this is what we're using. Questions that I can answer on example B. Any questions I can answer on this? We graphed an absolute value and a line. Okay. Example 2A is going to take a little bit more time than what we have. So we're going to skip to 2B because that one's shorter. So example 2, use a graph to solve each inequality. So now I have an inequality. Write answers as an inequality or a compound inequality. So directions now, instead of having equations, I don't have an equal sign. Now I have inequalities. And then if you want to write down A, leave like, I don't know, a third of a page, whatever, however big your graphs are looking. And then write down B. I'm only getting about 2 graphs per page. A will take a little more time because of the quadratic function. So we'll do B. B is x plus 3 is greater than 7 minus 3x. And I'll move it up in just a few seconds. The process is very similar. I am still going to graph y equals the left side and y equals the right side, even though it's an inequality. And then instead of looking only where they intersect, I'm going to look where the left function is greater than the right function. So I will graph y equals x plus 3. And I will graph y is equal to 7 minus 3x. All right, so we graph the first line, y equals x plus 3, which means I have a y-intercept of 3 and a slope of 1 over 1. The next equation, that's not written in the format that I'm used to seeing it. I'm used to seeing mx first, so I'm going to rewrite this as negative 3x plus 7. So that's what I'm used to, and I don't want to mess up my intercept and my slope. So for my red equation, I have I have an intercept of 7. So I'm going to start here. And a slope of negative 3 over 1. So I go down 3 over 1, down 3 over 1. I know I have an intersection, but this is not an equation, it's an inequality. So what I'm looking for is, where is x plus 3, the blue function, above or greater than the red function? And I'm going to write it out so that you've got it in your notes in case you're looking for it later. Where is x plus 3 above or greater than 7 minus 3x? Where is the blue function above, higher than the red function? So when I look, right, the red function's way up here, the blue function's way down here. So red is higher, red is higher, red is higher, red is higher. They meet, and then blue is higher, blue is higher, blue is higher, blue is higher, right? So where is x plus 3 larger than? Here. All of these x values is when x plus 3 is larger than 7 minus 3x. So the answer is like, let me see, like this section here. Or maybe I can highlight it. I don't know what's better. Maybe highlighting's better. Here. What are those x values? Because the x values are the solution. This is where x is 1. And these numbers over here are where x is bigger than 1. Does it include this point? No. It says, where is it bigger than? It doesn't say bigger than or equal to. I just want to know where the blue one is higher than the red one. So all of these values here are going to give me, are going to be part of my solution set. I can always check that by picking a number. Okay, great. Let's check this point right here, 3. All right. Is this point where x is 3 make this true? Yes. If I were to pick a point over here, like -1, it will not make this inequality true. Okay, we didn't get to all of our problems, but we are at the end of the period. So we will work on this. We'll do a little refresher tomorrow and then finish the notes tomorrow. I will post the assignment later today in case you really want to get it done and don't have time tomorrow.